Okay, so I might have figured out how to fix the microphone issue. I first start OBS without connecting the microphone, and then I plug in the microphone before starting recording. And it should be clean. So let's see. So today I am doing this at 7:30. So first time, and I choose a hard problem intentionally. Find minimum time to finish all jobs. So maybe scheduling. You are given an integer array jobs, where job size is the amount of time it takes to complete the if job. There are key workers that you can assign jobs to. Each job should be assigned to exactly one. Working time is sum of what he has to do, and you wanna maximum working time is minimized and return minimum possible maximum working time of any assignment. Okay, so there is just 12 jobs and 12 workers at most, and job sequence 10 to 7, but that's irrelevant. So not sure why. Okay, let's think about it. So there are many approaches to scheduling. Like we just give it to the guy with least amount of work to do. Like we have two guys, so we give them 8 and 7, and then we're like, who to give 4? Well, 7 has less of work, so give it to 7. And then we are like, 2, let's give it to 8. And then 1, let's give it to 8. And suddenly you finish in 11. So there is too many assignments. We cannot brute force them, because let's say we have 12 jobs and 12 workers, or you have like 6 workers and 12 jobs, and you just have to try, I don't know, a lot of options. I mean, let's just try sorting by the length and trying to do this. So let's n be the number of jobs, and then we do sort jobs begin, or we can do r begin and jobs r end to reverse it to go from maximum. Now we have some number of workers, so we do this, and now we iterate through jobs. If the job is less than, so if we didn't assign the job to all workers, we wanna have what, least amount of work. Probably we need set. I have a set which will store the work a worker has to do. No, that shouldn't be a set. That should be like a multi-set. Why not? I don't want to call it priority queue, if I'm being honest. I mean, I guess we can priority queue. I just don't remember if it's max or min. Let's see, but we can solve that. So let's do pq insert 1, pq insert 2, pq top. Won't build that return. There is no member insert. So maybe push. I'm not sure what is the API for priority queue, if I'm being honest. So output is 2, so it's maximum, which is what we need. Not really, but we can multiply the values by -1. So uh, but I guess if it would work this way, then the constraints wouldn't be small like this. So yeah, but let's try it just to see where it burns down. Well, what this could do is that okay, let's do pq insert minus jobs I, else we wanna do x is sum of jobs is gonna be at most what, 1.2 times 10 to 8, so that's all right. So x is pq top, and then we pop, and let's do minus, and then x plus equals jobs I, and then pq push minus x, and then we wanna, okay, so now we got the minimum in there and we wanna get the maximum out of them, so we have to pop all elements in the max, and then we while not pq empty int x pq top pq pop, and then we wanna do max minus x, and then we wanna return. I mean, I don't even have to do that, I can just do this, and then we return minus x. I insert again push. So to explain what I'm doing is that oh, that actually worked, but this is not gonna pass. Yeah, so for 5 5 and 4 4 4, well, you put 5 to one, 4 to the other one, and then you split 4 4 4, but that's gonna take 13, but you can do 5 5 and 4 4 4. So so how to do this? Okay, well, I mean, I could analyze time complexity, but it's clearly just a number of jobs. No. Yeah, number of jobs times logarithm of workers. Well, it doesn't work for that. Let's check my submissions and let's use this test case. And how to solve the problem of this test case. Maybe we could do subset VP. 3 to 12 is like, I don't know how much, but not more than 2 to 20, I think. Well, okay, let's try a backtracking solution. How would that work? So let's try backtracking. Let's switch to Python, because who wants to code memoization for that? Am I right? Let's sort the jobs, and then we wanna do is we wanna run some, I don't know, solve, which is on 0th index of jobs, and then has assignment of I don't know, like 0 times k, maybe. That doesn't seem good, but we will take it. And now solve, so let's call I and work, let's call it like that. If I is len jobs, then you return max work, and otherwise if we are not at last, we want to do this if len jobs minus I, so how many we are missing. So wait, each worker gets some subset. Each worker gets some subset of the jobs. So what I want to do is that I go through workers, okay, I got some idea. Each worker gets some subset of these. So we go through the workers. That's an interesting one. That might work. I feel like this might work. So we keep a mask of which jobs are taken and what was the minimum time it took, I think. I guess so. Let's call it the job take at least one, so I can pass 0. So let's say we first parameter is the number of the worker, index of the worker. Second parameter is the mask of taken, and then last parameter is minimum time it took so far. So min max so far. So if I is equal to k, then we return this. Otherwise, what we want to do is, well, we want to go through all submasks of now I wonder how it was done. There was a trick which could make it 3 to the power of n, but 4 could work, I guess. It could work. 12 times 2 to the 24 is like, nah, I mean that's a lot. I guess 2 to the 24 is million, 2 million. It's like, nah, I mean not sure if in Python it passes, but okay, so let's go through all submasks. For n mask, next, so work mask in range 1 to len jobs. If work mask and mask is 0, so there is no overlap, then hooray, we can doesn't equal 0, then we continue to make this simpler. So we pick some subset of work for if mask, so n is len jobs, let's call it that. Let's do this, and then so if the mask is full, so if negation, how can I make this efficient? So if negation of mask and 1 to the n minus 1, that is so stupid. That is ridiculous, bro. So if XOR of that is, I just want to check if the first whatever bits are set. So top is equal to 1 to n minus 1. Let's make it like that. So that's top, right? And we want to do if mask and top is equal to top, inf is, I don't know, 10 to 9. So we found that we are finished for some reason. So now return if we are at the end. Great, we can return min max so far if this works, else we return infinity. And now if we are not at the, we did not pick all jobs, but we are at the end of workers, then we return infinity. Infinity. Let's call it with 0 and infinity, and then return ans here, and then we go so we calculate the cost. So 4-bit in range n current, so we need to calculate work, so if work mask bit work mask bit and 1, work mask shift by bit and 1, then work plus equals jobs of bit. So this way we calculate the current work, and then we ans is minimum of ans and solve for I plus 1 mask and work mask and maximum of min max so far and work. And if I run this, it should run, maybe. So this should be 0. Okay, that worked. So let's do like okay, so let's make this a DP table. Will this even be fast? I'm not sure. This will TLE. Okay, it's TLEing, so we need to add some memoization or get rid of something. The min max is bothering me. So let's use some cache. That's not gonna work because I have the min-max on far, which can be many values. Could we do it without the min-max? Let's use this test case to analyze this. Okay, so I got some recursive-ish solution. Which I think works, but problem is with maybe this. Because let's say we compute it, this is top down, and if we do bottom up, that's a good question, honestly. Good question, good question. How does min-max go into this? So let's say, so I got first workers and they did these tasks, and what number I put in that cell? Well, I can't really put like Pinterest asks this question. That is crazy. Okay. So I got this. Now we can iterate over submasks in 3 to n. I'm not sure how yet, but you can. What about this min-max though? This is bothering me because if that ain't there, we are fine, bruh. Let's say you pick that subset, and what about it, you know? It's gonna take this much time, and now what we are interested in. And if you do it differently, minimum time it takes the longest guy. So actually you don't need this. You just calculate them. So you try, I try many subsets. So if I don't use this, then what is gonna be the answer? So what, you gonna return 0 or else infinity? And here if you reach the end but the mask is not up, you also return infinity. And then this is gonna be what? Because he returns some value and I take what? Maximum of that value and my value. So he returns some value and I take what? Max of work and this, maybe. Okay, that's still TLEs. But does it worked? Okay, now we are talking. So only optimization now is needed to go through all subsets. We don't want 2 to the n. We don't want n times 4 to n, but we want n times 3 to n. And that should pass, but I'm not sure what is the bit magic behind it. Maybe it's like I'm not sure, there is some negation and end, but you probably have to subtract something. Maybe it's like you end the number and one less than it. I'm not sure. I mean, the other thing is this is Python, so if I rewrote it into a table C++, it's gonna pass. Okay, let's try to rewrite it into C++. So we got number of jobs and then let's do like something is my so where was I? Okay, I want to check one thing. So let's say we have a mask which is like, I don't know, in binary, and then we do while mask and we do mask is so for int mask. How do you even iterate? Oh, how can you iterate over all subsets? I don't know how to print the binary number. And then we do mask is equal to mask minus equals mask and mask minus 1, maybe. I think this might work. But I'm not sure. Let's see. I got into some infinity loop, so I probably made up the formula. Why is there always one? That is weird. What? So this is the output. Print mask, mask. Print mask minus. It's gonna wait 10 seconds until it TLEs. Okay, thanks. So mask minus 1. I want to figure out the trick, but how is the mask suddenly 0, dude? What the hell? I don't know why it does this. I think this is the formula. Sorry if your ears died. I turn around and my neck hurts from the sneeze. That is crazy. But I'm gonna solve this, don't worry. Shit. Damn. Okay. Don't sneeze sideways, it's gonna hurt. Shit, okay. Let's check what this does. 0. That does only 5 masks. But I want more. That's not enough. It should do 1, 0, 1, 1 and stuff like that. Let's do free to NDP optimization. Sum over subset DP. Yeah, so this is 4 to n. So I minus 1. My dog is shouting, but shut up, stupid dog. Instead of now he's gonna disturb the entire video. So hopefully he's gonna be quiet for now. Okay, so this is the formula. Iterate over all subsets. So what's the proof? It's 2 to k, and there are n choose k bit masks, so you just do this. Okay. You take mask and you end it with okay, so I was almost right. You do int all mask is mask, and you do all mask, and this should work, I think. Yep, that works. Okay, so that was the only trick we needed. So okay, well, let's solve it, I guess. We do vector int dp and vector vector int of size 1 to drop, and then we go through so this should be initialized to infinity or not. I'm not sure. We will see. So let's go through the all workers and then go through each mask. Int power of n. Let's do pn. And let's do pn and mask plus plus. And now we want to go through all subsets of that mask. So we go so for int x is mask, x is 0, x is x minus 1 in the mask, and so that's a subset of it. So we need to compute the work for our submask, I guess, yeah, submask. So for int bit under n bit plus plus, if x shifted to bit and 1, then work plus equals job to bit. So now after we counted the work, we want to do dp of I mask is equal to minimum of dpi mask and maximum of, so I guess dp 0 0 should be 0, and then maximum of work and dpi minus 1 mask XOR x, and then we return dp and minus 1 pn minus 1. I haven't declared this, not XOR, but I also didn't want that. Close it. That's awesome. That is awesome. Crash 1. I think the crash is gonna be here, but yeah, it immediately crashes, so the mask actually shouldn't even be 1. And I should do I plus 1 and dp I plus 1 and n and dpi. Okay, well, that almost works, but it takes 200 milliseconds for all 4 cases, so it produces 8. That's weird. Oh, there is a typo. That's why. Okay, it still doesn't work. That starts to be worrying a bit. Haha, a bit. dpi plus 1 mask I plus 1. And then after we process the guy, we do this. So maybe I should have kept the binary print, void print int x while x salt x and 1. And then I should do like print of mask, I guess. Oh, okay. Okay, so that's way too many masks, bruh. We want to go through just the masks that have a count of, I mean, not really. You should consider all masks. That's gonna take 20. What am I evaluating? Let's do this. So it's 22. So at the end you can just do 1 in 5. How is this possible? So this gets set to That is weird. That is weird, bro. So to make the first 2 jobs with 2 people is gonna cost you 5. Okay, I believe that. This is gonna also cost you 5. To do first 3 jobs minimum with 2 workers is gonna cost you 5. 9, okay. 5, 5, 9, 4, 8, 8, 9, whatever. So to do the first 3 jobs with 3 workers, but I only have K workers, bruh. What the hell? Okay, that doesn't quite work. Okay, so with that simple trick we got the K times 3 to n solution, I think, and it took me 46 minutes, so I better hurry up because I have a lot of things to do, but whatever. Oh, looks like I did something absolutely unnecessary. Let's check the solutions. One branch binary search, greedy to prune. What? What the hell? So max element, so you sort jobs, you do result, what is result, bro? What the hell? What is result, bro? Oh, result is here. That is weird, bro. That's fair, I think. Okay, I mean I use this, but one branch cutting trick, what is that? So you have workers and you just DFS and you are here. You do minimum. Okay, and scene. Record search workload of workers. If workers I is seen, okay. If workers I, another branch cutting, okay. And if seen, so we did this, and then workers I this, and then we do what the hell. Okay, I got a better solution, and I got it by myself, just the optimization trick. So it's extremely slow, but no one cares. Subset dp, let dp I mask be the minimum time to split subtasks from mask to first I workers, minimum time, minimum time for the first I workers to finish the tasks marked 1 in the mask. We try to assign all possible subsets of of mask tasks to worker I and answer for DPI mask is the minimum answer over all subsets, and for each subset the answer is DPI DPI minus 1 submask plus work for mask XOR submask. In other words, the longest time to finish the shortest longest time to finish mask tasks with I workers is this is very hard to explain, but in other words, the shortest longest time to finish mask tasks with this is n squared, so I could actually pre-compute this. That might speed it up, maybe even by a lot. In other words, the shortest longest time to finish mask tasks with I workers is, in other words, we assign some tasks to worker I, and the last of them will finish, last of them will either be the ith1 if1 or the last of I minus 1 when solving mask, when solving the remaining tasks if 1, and the last of them will either be the if 1 or the last of I minus 1, or the last of I minus 1 when solving the remaining tasks, mask XOR submask. Answer for DPI mask is minimum over all such options. We can do two optimizations. First is to iterate over only subsets of mask with x minus 1 and mask submask by starting with submask equal to mask and iterating from what's that, binomial formula or something, from the binomial formula. I think that's what it's called. There are and choose k2 to the k. Sigma I0 to n, no, from n you choose k. It's submask. 2 to n minus 1, something like that. That is weird. I'm not sure how this works. So that is weird. So all this gets chosen with all this. Like that. Nope. Maybe like this. Okay, that is stupid, but whatever. Okay, c dot. So what this formula is that for each submask, Bro, I don't even know the formula. That is crazy. This is gonna have over 1 hour. A subset GP Usako. I don't know what the hell. For bit masks of there are n so total number of operations. I think this is the binomial formula. Binomial formula. Yep, binomial we will iterate over sigma k is 0 up to what n, so we choose how many ones. Finish this and then n, choose k, c dot 2 to k, which is equal to 1 plus 2 to k. That doesn't work for some reason. Okay, and choose k, maybe like this. This absolutely doesn't work yet. Whatever. 1 plus 2 to n, which is equal to 3 to n, instead of 2 to n, c dot 2 to n. Total subsets instead of this. First, iterate over this. Second, pre-compute work of each subset to decrease the time complexity from k times n times 3 to n to k times 3 to n. Note, I do not have this optimization in my code. Okay. Time complexity. Where k is the number of the workers and n is the number of the jobs. Okay, so as discussed in the approach section, space complexity is k c dot 2 to n to store the dp table. Yeah, okay. The answer is then dp n 1 to n minus 1, where n is the where k is the so I can delete it from here. Oh, this is this should be reformatted. I should be able to edit this, because this in the middle of it looks stupid. Okay, I have to very quickly write it up because I have a lot of things to do, but hopefully I can go to sleep sooner than 0:30. Good night.